Okay, so let's do some exam questions now. So let's start with this one. So we're given a 3D matrix here, or a 3x3 here, and we know it's a rotation around the y-axis because that's invariant. We're also told over here. Now the point P has coordinates 8, 3, 2. It's transformed to point Q under a reflection in the plane y equals 0. Write down the coordinates of Q. Now remember the matrix for y equals 0. The x and z axis are invariant, so it's going to be 1, 0, 0, something, 0, 0, 1, and the transformed j vector was 0, minus 1, 0. So the coordinates of Q are just going to be 8, minus 3, 2. And we can put equals Q. Since the identity matrix is just the same as this, except this is just 1. So changing this to a minus 1 would change this coordinate to minus 3. Okay, now part B. The point R is the image of P under the transformation rotation 120 degrees anti-clockwise. So that's positive, so it's going to be 120 degrees and not minus 120. About the y-axis with respect to the right-hand rule, so that's just basically plug in 120 over here, in degrees, not radians. So let's write 120 degrees anti-clockwise about y-axis. Well, cos of 120 is minus a half, so it's going to be minus a half. 0. Sine of 120 is root 3 over 2. 0, 1, 0. And then minus sine of 120 is going to be minus root 3 over 2. 0. And then cos 120 is minus a half. Now it's the image of P, so P is 8, 3, 2, so we can do matrix multiplication here to 8, 3, 2. So this gives us the new vector. Well, we're going to go row times column, so negative a half and 8 is minus that and that 0, that and that minus 1, so minus 4 root 3 minus 1. So the exact coordinates of R is just going to be root 3 minus 4, 3, and minus 4 root 3 minus 1. And we have got the mark scheme over here. So the coordinates of Q are 8, minus 3 and 2, which is got here. And R is minus 4 plus root 3, which is root 3 minus 4, 3, and minus 4 root 3 minus 1, so we've got that. So that is 3 marks over there. Now this one, part A. Describe fully the single geometric transformation A represented by the matrix A. Right, so x-axis is invariant, so it's going to be around the x-axis. So it's a rotation. Okay, let's put the amount first, so theta. So the matrix for a rotation around the x-axis is 1, 0, 0, 0 cos theta, sine theta, 0 minus sine theta, cos theta. Now we can plug in any one of those, so we'll just do cos theta equals root 3 over 2. Theta is equal to arc cos of root 3 over 2. 30 degrees, or 30 degrees, so we can put 30 degrees. Now in 3D I think the direction doesn't matter, but we can just put anti-clockwise anyway. And about the x-axis. Part B. Okay, so transformation B is represented by matrix B. A followed by B is C. Okay, so we've got A followed by the transformation B. Now, from successive transformations, we know that that's going to be the matrix of B multiplied by the matrix of A. So it should be this multiplied by this. But here they've done it the other way around. They've done this multiplied by this. So B, state the error made by the student. The student has multiplied AB instead of BA. That's the error made by the student. So part C, determine the correct matrix C. Well, matrix C is going to be BA. So BA is equal to, right, now let's multiply all this. So the top left number is going to be this times this. So 1 times 1 is 1. 3 and 0 is 0. 0, 0, 0. So 2 times minus a half is minus 1. And this is our matrix C. 3 by 3 multiplication, that is long. But let's see if we got the marks. Right, so I'll just keep the mark scheme here, I guess. Minus, yeah, matches. So that is 2 and 2, that's 4 marks right there. Now final question. So we've got the matrix for rotating about the z-axis. We're rotating alpha degrees anti-clockwise about the z-axis and determine the value of A. So basically we just have to equate. So cos theta is equal to minus root 3 over 2. Theta is going to be arc cos of that, so arc cos of minus root 3 over 2. And we get theta is 150. Now let's check that with minus sine theta and a half. So if minus sine theta is a half, sine theta is minus a half. So theta is going to be arc sine of minus a half. Oh, and here we get minus 30, but that's clockwise, so we want it in anti-clockwise, so put clockwise here. Now, minus 30 degrees clockwise is going to be 360 minus 30, which is 330 degrees anti-clockwise. Okay. But then is cos of 330 minus root 3 over 2? No, cos of 330 is positive root 3 over 2. Right, we've got a bit of a model here. So we know, so now we just find different values of theta. So cos theta, we know, is equal to cos of 360 minus theta. So what we can do is 360 minus 150, and we get 210, so 210. And the sine of theta is also equal to the sine of 360 minus theta. So theta is 360 minus 330, which is 30 degrees. Sine theta is sine of 180 minus theta as well. So that's 150. And then if we do 360 minus theta again, we get 210. So 210 is the matching one, and also 150. But sine of 150 did not match, it gave us positive a half, right? So let's try 210 because that's the other matching one. So sine of 210 should be minus a half, which it is, and cos of 210 should be minus root 3 over 2, which it is. So therefore, theta equals 210 degrees. That was a long one marker. So determine the value of A. Alpha is equal to 210. Okay, part B now. So hence determine the smallest possible positive integer value of k for which m to the power of k equals I. So our matrix here, the power of k equals I. Now we're in 3 by 3, so I, the identity matrix, is 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay, so m to the power of k equals I. Okay, so m, we know, is a rotation around the z-axis of 210 degrees anti-clockwise. So m to the power of k would be rotating 210 degrees anti-clockwise about the z-axis k times. If we had m squared, well, that's m times m, which is 210 degrees, 210 degrees. So that would be 420 degrees anti-clockwise about the z-axis. And 420 is 2 times 210. If we had m to the power of 3, well, that's just going to be applying the transformation 3 times. So that's 3 times 210. So m to the power of k is just going to be k times 210. So m to the power of k represents rotating around the z-axis 210k times. But this k needs to give these values to be just ones and zeros, like over here. So what we need is cos theta to equal 1, and sine theta to equal 0. Well, this happens when theta is multiples of 360 degrees. So we know that this 210k has to be related to this 360. So basically what we need to find is when they're like common with each other. So this 210 and 360, we just basically have to find the lowest common multiple, because at that point k will be a whole number and it will satisfy this. So the lowest common multiple of 210 and 360, well, to find this, well, 210 in prime factorization is 2 times 3 times 5 times 7, and 360 is 2 cubed times 3 squared times 5. Well, the lowest common multiple is just going to be the highest powers of each, so it's going to be 2 cubed times 3 squared times 5 times 7, which is 2,520. That's the lowest common multiple. But what value of k gives 2,520? Well, we said that it's 210k. So 210k is equal to 2520. So k is equal to 12. So yeah, so our answer to that is 12. Because the lowest common multiple of 210 and 360 is when, I guess, theta aligns, so this matrix becomes this. Okay, part C, I'll try it down here. 3x3 matrix N represents a reflection in the plane with equation y equals 0. Write down the matrix N. Right. Reflection in the plane y equals 0. We know that the x and z axes are invariant, so 1, 0, 0, and 0, 0. They're invariant. And our original vector of 1, 0, 1, 0, well, that gets mapped to 0, minus 1, 0, remember? So we'll get 0, minus 1, 0. So that is our matrix N. Okay, and part D, I might just do it on the next page. Let me copy this. Okay, so part D. The point A has coordinates minus 2, 4, 3. The point B is the image of point A under the transformation represented by M followed by N. Okay, right. m followed by n, we're going to multiply nm, other way around. So n, we said was 1 0 0 0 minus 1 0 0 0 1, multiply by m, right, minus, now just multiply the matrices. So row by column. Alright, so this is our matrix nm. So now we just have to reflect point A in it, so this matrix over here, we will multiply by the point minus 2 4 3 to get our new point B. So minus root 3 over 2 times minus 2 is just going to be root 3 plus 2 this and this will be minus 1 plus 2 root 3 and then 0, so 2 root 3 minus 1, and the last one, well that's 0, 0 and then 3. So representing this, and this is B, so now representing that as coordinates, B is equal to 2 plus root 3, 2 root 3 minus 1, 3. And this is our answer for what we had to show. Now part E. Given that O is the origin, show that to three significant figures the angle of AOB is 66.9 degrees. Almost 6-7. Okay, so if we just, I guess, sketch here. So AOB, so O is over here. A is minus 2 4 3. I have no idea where that will be. Let's just say here this is A, minus 2 4 3, and let's just say this is B. 2 plus root 3, 2 root 3 minus 1, and 3. So let's just create a triangle. Whoops. There. Okay, so 2 plus root 3, 0, 0. And we have to find this angle, let's say theta. Okay, so we can find this length, we can also find this length, and we can find this length. So it's just going to be cosine rule. So OB is going to be 2 plus root 3 all squared, so 2 plus root 3 squared plus 2 root 3 minus 1 squared plus 3 squared. So that's going to be square root of 29. AO will again just be everything squared, so minus 2 squared plus 4 squared plus 3 squared. So that's also just going to be root 29. And then AB, right, so using our distance formula, that's just going to be 2 plus root 3 minus 2 squared, so that's just going to be root 3 squared, which is 3, plus the y component subtracted squared, and this subtracted squared. So what we're going to get is so AB is going to be 56 minus 12 root 3 all square rooted. Well, using the cosine rule, we can say that cos theta is equal to b squared plus c squared minus a squared, so root 29 squared, which is 29, plus 29, minus a squared, which is 56, minus 12 root 3, all over 2bc, so 2 root 29, root 29. And this is approximately 0.0 0.392838. So now we'll just do inverse cos of this, so theta is equal to arc cos of 0.392838, and this is 66.86879018 degrees, which is approximately 66.9 degrees. So this is part E done, now part F. Hence determine the area of triangle AOB, giving your answer to three significant figures. Half AB sine C, well we know what C is, it's 66.9, so half AB, so root 29 times root 29, which is just 29, times sine of 66.9 into the calculator, and this is approximately 13.3 units squared. Alright, let's check the mark scheme now. So it is over here, and so 13.3, correct. Okay, well I hope this was helpful. This is now the end of Chapter 7 Linear Transformations in Core Pure 1. I hope it was helpful. Bye.